Hi everyone, today I brought a session on the topic of vernier calipers and screw gauge. Now these are instruments which are used to find length of a body in a more precise way. So by precise way, what do I mean? Let us try to understand. So think this is your normal centimeter scale which you have in your geometry box, right? Obviously I have zoomed it, I have shown a bigger representation for clarity. So obviously 1 centimeter is not this much big, right? Okay, so this is just a representation of our normal scale. So from here to here is 1 centimeter and there are 10 divisions. So one division here will be what length? Well, from here to here is 1 centimeter and there are 10 divisions. So simply divide 1 centimeter by 10. That will be 0.1 centimeter, which is also called 1 millimeter, right? So this distance, the smallest distance here which this instrument can measure, that is what we call generally as least count. So least count of any instrument is the minimum measurement, the minimum division that you can measure with an instrument is called its least count. So for this scale, remember you can measure minimum 1 millimeter. Okay. Now suppose you are measuring length of a body, and how do you measure it? Well, one end of the body you will keep at 0 and let's say the other end is exactly matching with the 1 centimeter mark. Okay, very lucky. Okay, so then what will be the length of this body? Obviously it will be 1 centimeter, this minus this, right? So quite lucky. But what if this end comes in between two marks? So let's say it is coming somewhere here. So what if one end of the body comes between two marks of the centimeter scale? Then what will happen now? So what will be the length of this body? Can you tell the length of the body exactly now? Obviously no, because see, one thing we can tell, it has crossed 1.3 centimeter because this is 1 centimeter, this is 1.1 centimeter, right? 1.2 centimeter and this is your 1.3 centimeter. So one thing is clear that the length of this body is 1.3 centimeter, but there should be some extra part here, right? A small gap here. Let us call this gap x. So x is basically the small distance between this dot line and the 1.3 centimeter mark on the scale. So the small gap is x. So that x has to be added to this, then only we will get the actual answer. Now the problem is, can you find this x in this scale? No, because this x is obviously smaller than the smallest division. The smallest division is distance between two marks, consecutive marks on the scale, and that smallest division is 1 millimeter or 0.1 centimeter, isn't it? So this x is less than 0.1 centimeter. So we cannot measure it with a normal scale. However, if you use vernier scale, which we will be discussing in this video, then you will come to know that this x we will be able to find. And let's take an example. Let's say this x comes out 0.03 because we know it is lesser than 0.1 centimeter. So lesser than 0.1 centimeter could be 0.03, right? So L will be how much now? 1.3 centimeter plus 0.03 centimeter. That would be 1.33 centimeter. So this would be a more better answer than 1.3 centimeter, isn't it? So if you use normal scale, then your answer can be given up to this only with confidence. So it has only two significant figures, right? But if you use vernier calipers, then you will be able to give even the third significant figure. So your number of significant figures will increase, and that is the meaning that this measurement is more precise than this measurement. Okay. Now some of you may think that x less than 0.1 centimeter can be 0.03 also, right? Yes. In that case, your answer will be even more better. So it will be not 1.33, it will be 1.303 centimeter. You will be able to give in that case 4 significant figures, right? and that is what we will learn in screw gauge. Okay. Now let me tell you how we measure length using vernier calipers. So the main concept is very simple. In a vernier caliper, you will have two jaws, like these jaws, right? One of the jaw will be fixed and the other will be movable, okay, like this, movable, right? So in a vernier caliper, one jaw will be fixed and the other jaw will be movable. First, what we have to do, we have to touch the two jaws, okay? After touching the two jaws, now whichever length we want to measure, that length we have to keep in between the jaws by moving the, obviously, the movable jaw. So imagine I want to measure this length. Then I have to keep this body in between the two jaws. Remember, this is fixed. So as I keep this object here, I need to move the other jaw, right? So whatever distance this jaw has moved, that is nothing but the length of the object. As simple as that. Okay, so one jaw will be fixed, other jaw has to be moved to keep the object in between, and whatever distance the movable jaw has to move, okay, so that distance moved itself is the length of the object. Now how do we do measurement with a vernier calipers? How do we take readings? Quite simple. In the fixed jaw, which I told, there will be a main scale attached. That main scale will be normally your centimeters scale, where there will be markings in centimeter. So each centimeter will have 10 divisions, so that each division will be 0.1 centimeter. They may change depending on the question, the division. In some questions they may give vernier calipers where each division is 0.05 centimeter. So that doesn't matter, but there will be a scale attached which will be called main scale. So main scale is attached to the fixed jaw. Okay. Now in the movable jaw, there will be another scale attached which will be called your vernier scale. So fixed jaw will have your normal scale, main scale, and your movable jaw will have a vernier scale. Okay. Now as an example, I have chosen a vernier scale where this upper one is showing the main scale and the lower one is showing the vernier scale. As you remember, the main scale is attached to the fixed jaw and the vernier scale is attached to the movable jaw, right? And just for an example, I have taken 4 divisions of main scale coincides with 5 divisions of vernier scale. Other combinations also possible. Okay, so don't think only always 4 divisions of main scale should coincide with 5. Sometimes it could be 9 divisions of main scale coincides with 10 divisions of vernier or other combinations. Okay. Now the smallest division between in a main scale, this is the main scale, right? So this is the distance between two consecutive marks in the main scale. So that distance x is what is called one main scale division. Similarly, the distance between two consecutive marks in the vernier scale, this is what is called your one vernier scale division. So y is equals to 1 vernier scale division. Now normally this smallest division in main scale is how much? 0.1 centimeter, right? Normally, but they can change this. Okay. Now as I told you, before we start the experiment, the two jaws should meet, right? And when the two jaws meet, let us assume the 0 of the main scale is coinciding with 0 of the vernier scale at the start. Now how do you measure the length? I told you have to move this vernier by keeping the object in between the two jaws, and whatever distance you moved, by whatever distance you move the vernier, that distance itself is the length of the object. Now in order to measure that distance moved, it is important that one of the mark in vernier, one of the division in vernier coincides with one of the division in main scale. This is the most important part. In order to do any measurement with vernier, it is important that as you slide this, one division of vernier should coincide with some division. It could be any division of main scale. Okay, so now can you tell me how much smallest can I move this? How much minimum distance can I move this so that one division of this or this or this coincides with one division of main scale? Can you check the diagram and tell? Obviously, this would be the smallest distance that you have to move so that this one coincides with this one, isn't it? Because for these two coincide here, you will need to travel more distance, but I told you smallest right now. So when you move that, what will happen? The diagram will change now. So this one will now come here. So let me rub this part. So the one will come here, and therefore this 0 will also shift this side, right? So the 0 will come here. Remember, this was the original position of this one, and this was the original position of the 0. So like that, all this will slightly shift by the same distance. Obviously same distance, right? Isn't it? If you move the marker like this, all the points will move by same distance. It's a rigid body, right? So it is 5. So how much distance you moved the vernier? Obviously you moved this much distance, and that is same as this distance, isn't it? So this is your y, if you remember, one vernier scale division, and the minimum distance that you can measure, or the length of the object, the minimum length of the object that you can measure is this, right? So this is the minimum, and that is equals to how much? If you see the diagram, this is x and this part is y. So if I remove this diagram for simplicity, you can easily understand this x minus this y will give you this length which you can measure, the minimum length. So it is x minus y. But what is x? One main scale division. What is y? One vernier scale division. And the minimum length that you can measure by an instrument is called least count, right? Least count. So this is the formula for least count in this particular scale. So now it is possible that in between one division of your main scale, there are actually two divisions of vernier. Okay, two divisions, not like previously where there was only one division. Now there are two divisions. So now if I ask you what is the minimum distance you have to move so that one of the mark will coincide with one of the mark in the main scale, one of the mark in vernier should coincide with one of the mark in main scale. So for that to happen, obviously you have to move by this distance, right? Then only this 2 will come here, right? That is the minimum distance you have to move the vernier, and that is the minimum length of the object which you can measure. So now the least count will be what in this example? This is your main scale division, and this much is your 2 vernier scale division. So you can see the formula doesn't match. So in this kind of vernier scale, usually this is not so common, but if they give this kind of vernier scale, you have to be careful to draw the diagram and then find the least count. Directly don't memorize this. Now we learned how to find the minimum length using vernier caliper, which is called least count. But what about other measurements? Well, as I told you, first you have to make the two jaws meet. That time the 0 of the vernier and 0 of the main scale should meet. Then you keep the object by sliding the vernier, right? Now let's say you move till here. So the 0 of the vernier reached here. Okay. So what will be this length? Which is the length of the object, right? So to find that length, what you have to do, you have to search for one of the division in vernier which coincides with one of the divisions in main scale. So let us search which division here coincides with which division here. So 0 obviously doesn't coincide, 1 doesn't coincide. You can see 2 is coincide, right? So since 2 is coinciding with 5, to find this length, I can simply subtract this length up to 5. If I subtract that length from this length, right? If you subtract this length from this length, you will obviously get this length because these two are coinciding, isn't it? This minus this is this. Simple geometry, line geometry. So now what is this length? Well, this is 5, so this must be 5 main scale divisions, and this is 2, so this must be 2 Vernier scale division. So this length will be 5 MSD minus 2 VSD. Correct? So this is how you are supposed to measure length of any object using Vernier caliper. Search for the coinciding Vernier division, whichever division coincides, and then subtract this length from this length. That's it. No formulas to by heart, but remembering formulas will be useful in some questions. So let me show you how the formulas which textbooks use, how that comes from here. Okay, so I hope all of you will agree if I write this MSD as 3 MSD plus 2 MSD and 2 VSD. I will keep as it is. So now you can see this is 3 MSD plus 2 common MSD minus VSD, right? Now try to see what is this. This 3 is the mark on the main scale which is to the left of the 0 of the Vernier. So when you keep the, as I told you, as you move the jaw, right, by keeping the object in between the two jaws, this 0 of the Vernier will move, right? So if the 0 is in between 3 and 4, if the 0 of the Vernier is in between 3 and 4, then this is your 3, right? So this 3 MSD represent this part. Okay, and that is what we call as main scale reading. So if 0 of the Vernier is in between 3 and 4, then main scale reading is 3 MSD. And 2, what is this 2? This 2 is the division in the Vernier which is coinciding with one of the division in the main scale. So out of all the divisions, 0, 1, 2, 3, 4, which one is coinciding? 2 is second division is coinciding. So this 2 is called coinciding Vernier division. So this 2 is called coinciding Vernier division. Okay, and this one, as I told you before, is nothing but least count, right? So this is the formula which you have seen in your lab when you do the Vernier calipers, right? Okay. But remember, this formula is coming by assuming least count is 1 MSD minus 1 VSD. But I told you that will happen in some cases. There are some few cases where least count may not be this. In that case, this formula will not work. But this method which I taught, this will work. Now let us quickly discuss zero error in Vernier calipers. Now what is zero error? To understand that, think of an ammeter. Okay, so this is an ammeter with marking 0 ampere, 1 ampere, 2 ampere, 3 ampere, right? And when no current is flowing, where the needle should be? It should be marking at, it should be pointing at 0 because no current is flowing. So if that happens, we say this instrument has no zero error. Similarly, when 0 of the Vernier was coinciding with 0 of the main scale when the jaws meet at the start, when there was no measurement done, that time 0 of Vernier and 0 of main scale coincides. In that case, we say there is no zero error. But suppose even when current doesn't flow, let's say the arrow is showing here, where even when no current flows, then in this case we say there is a positive zero error because it is showing positive, right? It's showing +1 current even when no current flows. So in that case we say the error is positive zero error. However, when you pass current, let's say 2 ampere, so actually you are passing 2 ampere current, but it will show where? It will show 3 ampere, right? So whatever you measure, if this is your measured value, okay, you are measuring 3 ampere, but there was zero error of how much? +1 ampere. Now to get the true answer, what I should do? Add this +1 or subtract? Obviously subtract -1. Then only you will get the right answer. So if your zero error is positive, you have to subtract from the measured value to get the true value. Okay, so if zero error is positive, if zero error is positive, then to get the right answer or the true answer, what we should do, whatever value you measured, you have to subtract the zero error. Okay. Now for Vernier scale, how do we find the zero error? So as I told you, if before doing the measurement, before putting the object in between the jaws, what we should do, we should make the jaws meet, right? Now when the jaws meet, if the zeros do not match, then we say there is a error, there is a zero error. And if the zero of the Vernier is to the right of the zero of the main scale, then we say there is a positive zero error, because it is showing some positive value, right? So what is this distance? This is your error, and in this example the error is positive, so positive zero error plus e, and therefore the true length will be equal to whatever you measured using the previous formula, right? Measured length minus whatever error we found. Okay. Now how to find this error? Again, to find length using Vernier scale, same technique you have to see. Wherever coinciding that you find, then subtract this distance from this distance, isn't it? From this, if you subtract this you will get. However, you can also use a shortcut formula, which is search for coinciding Vernier division. So here 3 is coinciding, then multiply with least count. So that is how you can find the error. Search for coinciding Vernier division, okay, when the jaws meet, and multiply with least count. Or you can directly do this way. This is 3 MSD, right? And this is 3 VSD. So if you subtract this from this, 3 MSD minus 3 VSD, 3 common, this is also your error. And you know that this is least count, right? So after understanding positive zero error, where the zero of the Vernier was towards the right of the zero of the main scale, it is possible that you may get negative zero error, where zero of the Vernier is to the left. Okay, so in that case, how to find the zero error? Let us try to understand. So I have taken a special case of 4 main scale divisions coinciding with 5 Vernier scale divisions. Okay, now if this happens, then we know there is no zero error, right? So no zero error. But here is, as you can see, zero of the Vernier is to the left, so there is this much negative zero error, right? So this time the zero error is minus e, and therefore while calculating the true length, whatever is the measured length, to that you have to add the error. Okay, take the mode of this and add. Try to remember this. If zero error is positive, like in the previous case, true length was what? Measured length minus the magnitude of the error. Similarly, if your error is negative, zero error is negative, then you have to add the magnitude of the error. Okay. Now how to find this e? How to find this magnitude of e? Well, the shortcut formula is the error is equals to, first you have to search for whatever is the coinciding Vernier division. You can see 4th is the coinciding Vernier division. Now previously what we did, whatever is the coinciding Vernier division when the jaws are meeting, right? When the jaws meet, if the zeros do not coincide, then only we say there is error, right? So if you have to search for coinciding Vernier division, here you can see 4th one is coinciding, right? None of the other divisions of Vernier are coinciding with the main scale divisions, right? So it will be this into least count, you may think, but that is not the correct answer. If your error is negative, if your zero error is negative, like in this case, then you have to count how many total number of divisions are there, 5, then 5 minus the coinciding Vernier division into least count. Okay, so this is your total number of divisions. Okay, so in this case it would be 1 into least count, so that would be your magnitude of the error. Now why do we need to do this actually? Okay, well, it's quite simple. You can see 4 divisions I assumed in the main scale coincides with 5 divisions in the vernier scale. So when I made the jaws meet, this instead of coinciding this way, the 0 is slightly here, which means this 5 also will come slightly here. So this error is also equal to this error, right? And now to find this error, I can just subtract this division, which is 1 MSD, with this division, which is 1 VSD. So your E will be simply 1 MSD minus 1 VSD. This can be written E is equals to 1 into least count. MSD minus VSD is least count. But this one is not this one, remember, right? Because this one is not the coinciding vernier division. The coinciding vernier division is actually 4. So how to get 1? From 5, the total number of divisions, you have to subtract the coinciding vernier division. Then you will get this one. Okay. So that is how you have to calculate the 0 error if the 0 of the vernier is to the left. So just search for the coinciding vernier division. Okay. Then subtract the total number of divisions with the coinciding vernier division and multiply with least count. Or you can count the coinciding vernier division from the last division. So from here, if you count, this is the first coinciding vernier division. So 1 into least count. So either way you can do. You can also find the negative 0 error by simply subtracting this distance from this distance, isn't it? So search for the coinciding vernier division, subtract this 4 VSD from this distance, which is 0, 1, 2, 3 MSD. So that will also give you the 0 error, the magnitude of the 0 error. Okay. Here is the first question. I'll do this question first using formula, and then I will show you without using formula, just by using line geometry, we can easily solve the same question. So first we'll do using formula. So for formula, we need to calculate least count and everything, right? So let's do. So the question says the smallest division on the main scale is 0.1 centimeter. Smallest division matlab what? Distance between two consecutive marks on the main scale, and that is nothing but our 1 MSD. Correct? Then they told 10 divisions of vernier corresponds to 9 divisions of main scale. So just like I took, if you remember, 5 divisions of vernier coincides with 4 divisions of main scale. Here they have taken 10 divisions of vernier coincides with 9 divisions of main scale. Okay, you can put this in a formula. How? Like this: 10 VSD, so 10 vernier scale divisions will match with 9 divisions of main scale, means what? 9 MSD. Okay, so this is given in the question. Then when the jaws meet, that is how we start the experiment. When the jaws meet, this is how the vernier and the main scale looks like. So you can see the zeros are not meeting. In fact, the 0 is towards the left. So that means it is a situation of what error? 0 error obviously, but negative 0 error or positive 0 error? Negative 0 error, right? So this is a case of negative 0 error. And then they have put a sphere in between the jaws. So when a sphere is in between the jaws, that time this is the reading between the main scale and the vernier scale. And we are supposed to find the diameter of the sphere, the true diameter. Okay. So first, as I told, we will use formula, and for formula we need least count. So 10 vernier scale divisions are coinciding with 9 main scale division, and yes, you can see this is your 1 MSD, right? Distance between two mark. Okay, before I used to write here 0, here 1, here 2, here 3, here 4, here 5, like that. Okay, in the previous diagrams I made it bigger so that it was clear. So now this you have to understand is the 0th division, first, second, third, fourth, fifth, and the distance between any two consecutive mark will be how much? 0.1 centimeter, because this is 1 centimeter. So this small gap will be 0.1 centimeter. 1 centimeter divided by 10. So from here, what will be 1 VSD? Divide by 10 both sides. 9 by 10 MSD. And this is 0.9. What was main scale division? 0.1 centimeter. So this is 0.09 centimeter. Right? So one Vernier scale division is 0.09 centimeter. Keep that in mind. Now least count formula was what? 1 MSD minus 1 VSD. Right? So 1 MSD is 0.1 centimeter minus 1 VSD we found from the given information 0.09 centimeter. That will be 0.01 centimeter. Right? So this subtraction you should be able to do. Okay. So the least count, let me write it down here, is equals to 0.01 centimeter for this Vernier calipers. Now because there is zero error, let us try to calculate the zero error. Okay. So zero error will be equals to, first you have to search for coinciding Vernier division. So try to zoom this, if in the video try to zoom and see which one is coinciding. For me it's easy to find out. So 0 is not coinciding, 1, 2, 3, 4, 5, 6th. So the 6th division is exactly coinciding. But don't write 6 into least count. That we do if the zero error was positive. Here the zero error is negative. So minus 6th one is coinciding and the total number of divisions are 10. So I should write 10 minus 6, right? Or you count from here. So 0, 1, 2, 3, 4. That is how you should do. So this is the coinciding Vernier division when you count from the back into least count. So that is minus 4 into 0.01, which is minus 0.04 centimeter. So this is the zero error. Now this diagram was when the jaws meet, remember, right? And that is used to find zero error. Now when the sphere is kept between the jaws, this is the diagram. So let us use now this diagram to find the measured value of the diameter. So what was the formula for the measured length? So the measured length, in this case the measured diameter, right? What was the formula? Main scale reading plus coinciding Vernier division into least count, right? See, first I told you I'll use formula. Now what is the main scale reading? Main scale reading is the, let us check where the zero of the Vernier is. So can you see the zero of the Vernier is between this division and this division, right? This division is how much? 3.1 centimeter and this division is 3.2 centimeter. The zero of the Vernier is not exactly coinciding with this. It is slightly on the right side of this 3.1 centimeter mark. So therefore, since the zero of the Vernier is between these two, what is the main scale reading? This fellow, right? The lesser one. So 3.1 centimeter plus. Which one is the coinciding Vernier division? You can see this itself is coinciding. Please zoom the diagram in the video and check. So this is coinciding. So this is the first division, right? So this is the first division. So coinciding Vernier division is 1. Remember, this is just division. So don't put any unit here, okay? So coinciding Vernier division is 1. No unit here. And least count we already know is 0.01 centimeter. So that will give you this is 0.01 plus this will be 3.11 centimeter, right? This is the measured length. So what will be the true length? So true length in this case will be measured length plus the magnitude of the zero error. What is the magnitude of zero error? 0.04. That will give you 3.15 centimeter. So that would be the answer. Okay. Now without using any formula, let us try to find the zero error and the diameter of the sphere. So you remember, right? This is the zero error, this gap. So how to find this gap? Well, this division of Vernier is coinciding with the 5th division of your main scale. So this can be written as, what is this one? 6th division of Vernier, right? So therefore this gap will be 6 VSD. This is 0, this is first division, second, third, fourth, fifth. So this is the 5th division. So this gap will be how much? 5 into main scale division. Remember, this 5 is not 5 centimeter, okay? This is 0.5 centimeter. But right now we are only counting the division. So 1 division, 2, 3, 4, 5. So this E is obviously this whole distance 6 VSD wherever it is coinciding minus 5 MSD. Finish now. This is 5, okay? What was VSD we calculated? 1 VSD was 0.09, right? Minus 1 MSD was 0.1. 6 into 0.09, 0.54, right? 6 9s are 54, minus 0.5, which is 0.04 centimeter. It's the same answer we got, right? But here we will get the magnitude because we are subtracting bigger minus smaller, right? Now, how to find the diameter of the sphere directly without using formula? For that, we have to look at this diagram. And remember, I told you from the beginning, I am telling you that the distance moved by the vernier, that itself is the length of the body. Now, before, your 0 of the main scale was here, right? And the 0 of your vernier was here. Let me use the red color for vernier. This was the 0 of your vernier previously, as you can see. So now you moved this vernier till here. So 0 moved till here, right? Remember, this gap is E. Now which division is coinciding? This division is coinciding, already we discussed, right? The first division is coinciding. First division of vernier is coinciding, right? So concentrate on that one only. So remove all these things now, no need. And remove all this. So now we came to know which division is coinciding. This is, so from here to here, how much? This 3 matlab how many divisions are there? 30 divisions, right? Because this is 3 centimeter. 1 centimeter has 10 divisions. 1 centimeter has 10 divisions. So 3 centimeter has 30 divisions. So up to here 30 divisions. Then this is 31, 32. So from here to here is 32 MSD, isn't it? From 0 of the main scale to this division is how much? 32, because 3 centimeter means there are 30 divisions already. Or you can directly say this is 3 centimeter, so 3.1, 3.2. So this is 3.2. So you can also say 3.2 centimeter, this length. Because 1 MSD is how much? 0.1. 0.1 into 32 is what? 3.2, right? So this length is 32 MSD. And our length of the diameter is this, remember. This is our true length. And this part is E, remember. And this is how much? This is 1 VSD. Why 1? Because this is 0, this is 1. So look carefully. This L, the length of the, here the diameter of the sphere, the true length, because we are including this E also, right? So since we are including this E also, it is the true length. So directly you will get true length. So this L is equals to this E plus this 32 MSD, which is 3.2 centimeter, plus, not plus, minus this 1 VSD, right? Because the length is up to here only, right? But this is the 0 of the vernier. This is the 0 of the vernier. So this is the 0 of the vernier. After you put the sphere. So this was the 0 of the vernier when the jaws were meeting. Then you move the jaws. Whatever distance you moved, that itself is the length of the diameter of the sphere. And this distance moved is this E plus this 32 MSD total minus this 1 VSD minus. So that will give you what answer now? E was how much? 0.04, right? Plus 3.2 minus 1 VSD is 0.09. So that will give you 3.24 minus 0.09. That will give you 3.15 centimeter, right? So this is the same answer as we got previously. So let me finally tell you once. So search for the coinciding vernier division with the main scale. So suppose this is coinciding. Then this is the initial position of your 0 of the vernier when the jaws were meeting, right? And this was your 0 error. These two didn't coincide. Otherwise, normally these two would coincide, right? If there was no 0 error. And this distance, how much distance the 0 moved, that is the length of the object which we want. So this L will be what? This E, and this is the reading on the main scale, right? So in this example, that was your 32 MSD, right? Because this was your 32nd division, and this was your first division. So this was your 1 MSD, sorry, 1 VSD. So this L plus 1 VSD should be same as this E plus 32 MSD. So from here L will be this, you take that side, you will get the same answer. Okay. So let's solve the next question. It says two vernier scales C1 and C2 where 1 centimeter is divided into 10 equal divisions. So here you can see, so from 3 to 4 there is 1 centimeter gap. There are inside 3 to 4 there are 10 divisions. Okay. So one main scale division for both the scales will be 1 centimeter divided by how many divisions? 10 divisions, right? So that would be 0.1 centimeter. So that would be the one main scale division for both the scales. Now for the first scale, 9 vernier scale divisions are coinciding with 9 main scale divisions. So this is your normal scale which we have used till now. Okay. So in the scales that we have been discussing, if you remember, this number is more than this number, right? In the first example I took, it was 5 vernier scale divisions were having 4 main scale divisions. In the previous question we did 10 vernier scale divisions is equals to 9 main scale divisions, right? So for C1, let us calculate what is the value of 1 VSD. So 1 VSD will be divide by 10 both the sides. So 9 by 10 MSD. Already we did this, right? Similar calculation. So 0.9 MSD and 1 MSD is 0.1 centimeter. So 0.09 centimeter. Here if you calculate the least count, it will be 1 MSD minus 1 VSD, which will equal 0.01 centimeter, exactly like before. Okay. So try to remember this. For scale C1, what is 1 VSD? Let me mention here. 1 VSD for the first scale is 0.09 centimeter. Okay. Let us try to now calculate 1 VSD for the second scale. Now for the second scale they have given 10 vernier scale divisions is equals to 11 main scale divisions. So this number is more than this number this time. Such scales are not normal. Okay, they are slightly abnormal. Let's see why we are calling it abnormal. So for second scale, what will be 1 VSD? Just divide both the sides by 10. So 11 by 10 MSD, 1.1. 1 MSD was 0.1 centimeter. Multiply this 0.11 centimeter. And now you can see this is greater than 1 MSD, right? 1 MSD was 0.1. This is 0.11. So therefore, if you use the normal formula of least count, 1 MSD minus 1 VSD, you will get negative answer, which is not possible. So therefore, now you cannot solve the problem by using the regular formula given in textbooks. So we have to do it using the line geometry. which I told you. Okay, so let us now calculate the reading given by the two scales. Okay, so let's start with the first scale. Now first scale is normal, so we can go with formula if you want. So just search for the coinciding Vernier division. So which is the coinciding Vernier division? Look carefully, 5th one, 6th, 7th, this one, right? So coinciding Vernier division is 7. What is the main scale reading? So for that you have to see where is the 0 of the Vernier. This is what division? If this is 3, this is 2.9 centimeter. So here it will be 2.8. Okay, so that I should have shown you. So this 0 is between 2.8 and 2.9 centimeter. So main scale reading is 2.8 centimeter. Or you can also say 28 MSD, right? Now the formula is for the length, main scale reading plus coinciding Vernier division into least count. What was the least count for this? 0.01, right? So that will give you 2.8 plus 0.07. So that will give you 2.87 centimeter. So this is how we can get the answer using formula. Without using formula directly can we solve? Yes. So since there was no zero error, okay, when the jaws were meeting, the 0 of the main scale and 0 of the Vernier, wherever it is, they must be coinciding. So this is the initial position of 0 of the Vernier. They must be coinciding. Then to keep the object, you will slide the Vernier, right? So now this is the length of the object. Now how to find this length? Look carefully. This is coinciding. So from here to here, tell me that distance. Let me rub this. Let me keep it there only. Let me remove all these things. This is 3, remember. It's 2.8. Let me remove. Okay. Remember, I have to search for the coinciding Vernier division. So this is the coinciding Vernier division which is coinciding with this main scale, right? So from here to here. Yes. This is 30, 31, 32, 33, 34, 35. So you can say 35 MSD, or you can simply say this is 3 centimeter, 3.1, 3.2, 3.3, 3.4, 3.5. So 3.5 centimeter. And this is how much VSD. Remember, this is the 7th division. So this is 7 VSD. So what will be L? Just line geometry. This minus this. So 3.5 centimeter minus 7 VSD. Right. What is VSD? We found 0.09. So that will be 3.5 minus will be 0.63, and that will give you 3.50, 0.63, 7, right? 10 minus 3, 7. This will be 4. This will be 8. This will be 2. So 2.87 centimeter. Same answer we got with formula also, isn't it? Now when we come to the second scale, we cannot use formula. So we have to use the line geometry which I taught. Okay. So again, there was no zero error. Thank you for that, right? Otherwise I have to take care of zero error also. So here is the 0 of the main scale which is fixed, remember, and this is the 0 of the Vernier initial. And this 0 has been pushed till here. So this is the length which we want. And again we have to search for the coinciding Vernier division. You can see here also 0, 1, 2, 3, 4, 5, 6, 7. Here also 7th division is coinciding. Now this is how much? 3. This is 3. So this whole length till where it is coinciding. Here remember, okay? Here. How much it will be? This is 0. Here 3. This is 3.1, 3.2, 3.3, 3.4, 3.5, 3.6. So this whole length is 3.6 centimeter. So this whole length is 36 centimeters. So length will be what now? 3.6 centimeter minus 7 VSD. 7 VSD. So 3.6 centimeter minus 7. What is VSD in this case? 0.11. So that will be 3.6 minus 0.77. 3.60 0.77, that will be 38.2. So now the answer is 2.83 centimeter. Okay. Let's do a slightly easier question. The question says in a Vernier calipers, one main scale division is x centimeter and n divisions of Vernier scale coincides with n minus 1 divisions of main scale. So since this is smaller than this is our normal scale, right? So we have to find the least count. So here it is given n VSD, n Vernier scale divisions coincides with n minus 1 main scale divisions. Okay, so this is what this sentence means, right? So from here, what will be Vernier scale division? 1 Vernier scale division. Divide both the sides by n. So n minus 1 by n MSD. And what is 1 main scale division? 1 main scale division is x centimeter. Right? So now least count for normal scale. What is the formula? 1 main scale division minus 1 Vernier scale division. So 1 main scale division is x. 1 Vernier scale division is n minus 1 by n times x. So if I take x common, I'll get 1 minus n minus 1 by n. So here LCM you will get here n minus 1 plus 1, right? Properly you take the LCM. This n will cancel, so it will be x into 1 x by n centimeter. So this will be the answer for the least count, right? Let's do the next question. It says a Vernier scale has 1 millimeter marks on the main scale. So in the main scale we have marks, right? So that marks are separated by 1 millimeter. So that must be obviously 1 main scale division, 1 millimeter or 0.1 centimeter, right? Now they told 20 divisions in Vernier scale coincides with 16 divisions in main scale. We have to find least count. So my question is this our normal scale or not? Obviously this is less than this, but we need to check in one main scale division, do we have more than one Vernier scale divisions? I discussed this in the first part if you remember. Okay, so let me try to check that. So if this is your main scale 0, 1, 2, 3, if these are the divisions in the main scale, then here we can see one main scale division will be divided by 16. So 20 by 16 Vernier scale division, and this will not come 2 point something, right? This will come 1 point something only. That means in one main scale division there is not more than one, obviously more than one, but not 2. It will be 1 point something. That simply means if this is the 0 of the Vernier, here there will be your first mark, because in one main scale division you have 1 point something. So this is 1 point something. So 2 will not come here. 2 will be outside this. I hope that is very clear. Okay, so once I got to know this, then I am very confident that I hope you remember this gap is the least count, right? The smallest distance the Vernier can move when this line coincides with this line. So that is the smallest distance the Vernier can move, and that is the least count, right? So it's very clear that least count in this problem is this distance, which is 1 MSD minus this distance, which is 1 VSD, right? So this minus this is this gap, which is least count. So this was your normal scale only. So 1 MSD is 1 millimeter. Now 1 VSD, how to find? Well, to find 1 VSD, we will do whatever we did before. So 20 VSD equals 16 MSD. Divide by 20. So 1 VSD will be 16 by 20 MSD, which will be 4 4s are 4 5s are MSD, and MSD is 1 millimeter. So this is 1 VSD is 4 by 5 millimeter, correct? And that will come out to be 5 LCM 5 minus 4 1 by 5 millimeter, which is 0.2 millimeter. Okay, so let's see this question now. Everything is same, but here I have given a scale where 10 vernier scale divisions coincides with 4 main scale divisions. So here also can I write least count as 1 MSD minus 1 VSD? Again you have to check whether in one main scale division do you have more than 2 divisions of vernier or not. And how to check that? Well, the best way is, if 10 VSD is 4 MSD, then in 1 MSD what to do? Divide by 4. So it's very clear this will be more than 2, right? So 2.5, isn't it? So in 1 MSD there is more than 2 vernier scale division. So if you draw the scale, it will look like this. So this is your, let's say 0 1 2 in main scale. This is 1 millimeter, remember, 1 main scale division. And then the markings of the vernier should be such that if 0 is here, 1 will not be there, because inside 1 MSD there are more than 2 VSD. So maybe 1 is here, 2 is here, and then 3 will be here. Then 2.5 will coincide here. So this will be your least count, isn't it? Why this will be a least count? Because as you move the vernier, this will coincide with this first time, right? So the minimum distance you have to move the scale so that one of the mark coincides with one of the mark in main scale is when this mark reaches this mark. So this much minimum distance you can measure. So how to find that distance? Well, this is 1 MSD and this is 2 VSD, isn't it? So least count will be what now? 1 MSD minus 2 VSD. And how to find VSD? From here 1 VSD will be what? 4 by 10 MSD, which is 0.4, and 1 MSD is 1 millimeter. So this is 0.4 millimeter. So 1 MSD is 1 millimeter minus 2 into 0.4 millimeter, which is 1 minus 0.8, which is 0.2 millimeter. So this would be the least count, right? Let's see the next question. It says a vernier caliper has no zero error. So no zero error, so we can forget about measuring the zero error, and it is used to measure diameter of a cylinder. Okay, the zero of the vernier lies between 5.10 centimeter and 5.15 centimeter of the main scale. So if this is your main scale, if this division is 5.10 centimeter and this is 5.15 centimeter, the zero of the vernier lies between these two. Okay, somewhere here maybe. So this is the zero of the vernier. So from here immediately we can tell what is the main scale reading, right? So the main scale reading would be the lesser one, right? So it will be 5.10 centimeter. Of course this reading is with the cylinder in between the jaws of the vernier caliper, right? Okay. So main scale reading already we found. Now they told the vernier scale has 50 divisions equivalent to 2.45 centimeter. So the vernier scale here has total 50 divisions. 50 divisions are there, and the length of this is equals to 2.45 centimeter. So what would be the one division of vernier scale? So one vernier scale division would be simply the total distance 2.45 centimeter divided by 50 divisions, right? Okay. Now this will be equal to 5 ones are 5 zeros are, right? And this will be 5 fours are 20, 4 carry, 5 nines are 45. So here point will be there, right? So 0.49. Let me remove this part. So 0.49 divided by 10 will be 0.049 centimeter. So that would be the one Vernier scale division, right? Okay. Then they told the 24th division of the Vernier scale. So here, out of all the 50 divisions, the 24th division coincides with one of the marks in the main scale. So that means this 24 is nothing but CVD, right? Coinciding Vernier division is 24. So now we will calculate least count and then we'll use the formula to find the diameter of the cylinder, right? So the least count formula is 1 MSD minus 1 VSD. Okay. When nothing is mentioned, better to assume the Vernier caliper is the normal one. Okay. So what is one main scale division? Well, one main scale division means distance between two consecutive marks, right? So I will assume these two marks are consecutive. They didn't mention it, but we have to assume it, right? So this distance is your 1 MSD. So 5.15 minus 5.10 will be how much? 0.05, right? Centimeter. So one main scale division will be 0.05 centimeter minus one Vernier scale division. How much we found? 0.049 centimeter. That will be 0.050, 0.049, that will be 100.0. So the least count will be 0.001 centimeter. So now we can use the formula to find the diameter of the cylinder. Remember here there is no zero error, so whatever is the measured value, that will be the true value. So no need to add or subtract the zero error, right? So diameter would be main scale reading plus coinciding Vernier division into least count. Okay. We also call this coinciding Vernier division sometimes as Vernier scale reading. Okay, VSR. VSR. So that would be how much here? Main scale reading was 5.10. Coinciding Vernier division is 24. Least count is 0.001, remember. So this will be 5.10 plus this into this will be 0.024, and that will be 5.124 centimeter. So that would be the answer for this question, right? Now let's do this wonderful question. In a Vernier scale, 10 Vernier scale divisions are coinciding with 4 main scale divisions. So if you remember this question we have already done, right? And here if the main scale is in millimeter, if the marks are in millimeter, then the least count of this we found to be 0.2 millimeter. Okay, please check that one. Now when the jaws meet, that means when you are trying to find the zero error, you want to check whether there is zero error or not. The zero of Vernier is to the left of the zero. That means there will be a negative zero error, right? Of the main scale, and fifth division of Vernier coincides. Okay, so this arrow basically means coincides with 1 millimeter mark on the main scale. Okay, so for this the diagram would look something like this. Okay, this is the 0, this is the 1 millimeter mark, 2 millimeter mark. Okay, then the 0, first of all the 0 is here, remember. So there is a negative zero error, right? E, magnitude is E, this gap. And fifth division, here fifth division of the Vernier coincides with 1 millimeter mark. Okay, so from here easily we can find E, isn't it? So this diagram try to remember. Then they told when the object is kept in between the jaws, matlab when you want to measure the length of the object which you have kept between the jaws, the second division of vernier coincides with 23 millimeter mark. So let us try to show this also. So let me rub this part and just show that second division of vernier, the red color, is in coinciding with the 23 millimeter mark. So we have to find the length of the body which is in between the jaws with regard to error. So we have to mention plus minus any error. And whenever we put plus minus error, that is called random error, right? Because we are not sure what sign it has. So we are putting plus minus some error. So since this is not our normal scale, we will not use the formula and we will try to use the line geometry. Okay. So this is your main scale, right? 23 millimeter mark is somewhere here, let's say. And which division is coinciding? Second division is coinciding. So first may be somewhere here, 0 may be somewhere here, right? Okay. And initially, remember the 0 of this scale, this scale is fixed, right? So 0 is here, somewhere here, isn't it? And that time the vernier was initially here. This was the 0 initial, right? And that time this was your E, let's say. So what we will do, first we will try to find E from this diagram. Okay, let's rub this diagram with that one I have drawn here. Okay, so before doing that, let us calculate the value of one vernier scale division. So they told in the question 10 vernier scale divisions is equals to 4 main scale divisions, isn't it? So one vernier scale division will be 0.4, right? Divide by 10, main scale division, and that is 0.4 millimeter, because this main scale is in millimeter, right? So each mark is separated by the next mark with a gap of 1 millimeter, right? Okay. So from this diagram, let us try to calculate the error E. So you can see from here to here, this is 5, remember. So this is 5 vernier scale division, and from here to here is 1 millimeter, isn't it? This is 1 millimeter. So E must be equal to, from this 5 VSD, you need to subtract this 1 millimeter or 1 MSD. You can write 1 MSD first. What is the problem? So 5 vernier scale divisions. One vernier scale division is 0.4 millimeter minus 1 main scale division is 1 millimeter. This is 0.4 millimeter. So this is 2 minus 1, 1 millimeter. So the magnitude of this E, the value of this is E is 1 millimeter. If they ask 0 error, then you have to write minus 1 millimeter, minus 1. 0 correction if they ask, plus 1 millimeter. Okay. Now what is the length of the body? Well, that already we have learned so many times. It is the distance moved by the 0 of the vernier. This is the length. Now look carefully. This is the second division of vernier coincides with the 23 millimeter mark in the main scale. So this part will be how much? This will be 2 VSD, right? And from 0 to this will be 23 MSD, which is 23 millimeter also. And this is E. So this total distance L plus 2 VSD must be this E plus this remaining part, which is 23 millimeter, right? So L will be 2, what was vernier scale division? 0.4. E value is 1 millimeter plus 23 millimeter. So L will be, this will be 24 millimeter minus, remember this 0.4 is also in millimeter. So this will be 0.8 will go that side. 24 minus 0.8 will be how much? 24.0 minus 0.8. So that will be 23.2 millimeter. Now don't consider this E as a random error. Remember, it is an instrumental error, right? It is a specific sign. So it is a systematic error. But the random error here is the least count error. Okay. So our final answer should be reported. The final report of the measurement should be done 23.2 millimeter plus minus the random error here is the least count, which is 0.2 millimeter, which we did in one of the previous question, right? Now let's take a very unique question. So here the question is saying if 11 main scale divisions equals 10 vernier scale divisions in some vernier caliper, then we have to find the least count. And they've given one main scale division equals 1 millimeter. Okay, so the gap between two marks in the main scale, the consecutive marks are separated by 1 millimeter. Now normally this number will be smaller than this number, right? Like before we did 9 main scale division coincides with 10 vernier scale division, right? So from here we found 1 vernier scale division, divide by 10, you get 0.9 main scale division, and then least count we did 1 MSD minus 1 VSD, isn't it? But now for this question, if you check your 1 VSD, if you divide by 10 both sides, you will get 1.1 MSD, right? If you divide by 10 both sides. That means least count now will be 1 MSD minus 1 VSD is 1.1 MSD. So this is 1 minus 1.1, this will be negative. But negative least count is not possible. Every instrument should be able to measure some minimum distance. How that minimum distance that you can measure is negative. So something wrong is going on. So such kind of scale where this number is greater than this number, there we cannot use this formula to find the least count. Such scales are called retrograde vernier calipers, where if this is n divisions of vernier scale, this will be n plus 1. Whereas in normal scale, if this is n divisions in vernier scale, the number of divisions in main scale which coincides with n vernier scale divisions is n minus 1. So this is your normal scale, this is your retrograde scale. Okay. So if we can't use the formula, then how to find the least count here? Well, let us draw this 11 main scale divisions. Okay. So here I have shown the diagram where they told 11 divisions in main scale coincides with 10 divisions of vernier. That means the 0 here is coinciding with 0 here, and the 10th division in vernier is coinciding with 11th division in main scale. Now where will be the first division in vernier? Will it be here? Well, if it was here, then this would be the minimum distance that you have to move the vernier, and that minimum distance to be moved so that this coincides with this, right? So that minimum distance would be the least count, and that would be simply 1 MSD minus 1 VSD, isn't it? But here this is not the case, because your 1 vernier scale division is not smaller than 1 main scale division. Actually 1 vernier scale division is greater than 1 main scale division. You can check from here, right? Already we did. So if you divide by 10 both sides, you will get 1 VSD is 1.1 MSD. And what is main scale division? 1 millimeter. So 1 vernier scale division is how much? 1.1 millimeter. So since this is 1 millimeter, 1.1 will be beyond this line, isn't it? So this will be the first division in vernier. So this is your 1 VSD, which is 1.1 millimeter. So this small gap, okay, try to zoom the diagram and see. So the gap between this first division of vernier and first division of main scale, that gap will be how much? 0.1 millimeter, right? 1.1 minus 1 MSD. Now where will be second division? If this is here, well, second division will be here, right? and this gap will be how much? 0.2 millimeter. Why 0.2? Because from here to here 2 VSD, right? 2 VSD will be 2.2 millimeter and 2 MSD is 2 millimeter. If you subtract, you will get 0.2 millimeter. So second division is how far from second division of Vernier is how far from second division of main scale? 0.2. So this gap is 0.2. Okay, so let me remove this now. So this gap is 0.2 millimeter. So similarly, the third division will be how far from the third division of main scale? 0.3. This will be how far? 0.4. This will be 0.5. Keep watching. Sixth division will be 0.6. This will be 0.7 millimeter. Eighth division will be how far? This will be 0.8 millimeter, right? Ninth division will be here. How far from the ninth division of main scale? 0.9. And the 10th division will be obviously here because this should be how far? This is 0.9, so next will be what? 1 millimeter, right? And that is the gap, right? The gap between the main scale divisions are 1 millimeter. So now the 10th division is 1 millimeter far from the 10th division of main scale. So as you can see, this gap was 0.1. The distance between first division of Vernier and first division of main scale. This gap is 0.2, which is distance between second division of Vernier and second division of main scale. So that way this gap keeps on increasing, isn't it? So now, how do you do measurement with Vernier? I told you have to move the zero of this Vernier scale this way, right? You have to slide, and whatever distance you move, that is the length of the object. Now, how much minimum distance you should move the Vernier so that one division of Vernier coincides with one division of main scale? Now, you may think, sir, this much we have to move, this much, right? Because remember, we are moving right side. So, if you think this is the minimum distance so that this will coincide with this, then that is wrong because this is not the minimum, right? You can see this is lesser than this, isn't it? Because this gap is more than this gap, so this gap will be lesser than this gap. So this is not the minimum distance by which the Vernier should be moved so that the Vernier division coincides with main scale division. What is the minimum? So you can see this is lesser, this is even lesser, this is lesser, right? This is lesser, this is even lesser, even lesser, even lesser, and this is the least division, isn't it? So this is the smallest division by which if you move the Vernier this side, this division will coincide with this main scale division. So this would be your least count. So that is how we have to find the least count. So what will be least count? Equals to now. So if you look carefully, this is the 10th division in your main scale, right? So from here to here will be 10 MSD. Till here. This red color you see carefully. So this red mark, which is the 10th division. So this distance is 10 MSD. And from 0 to here is your 9 Vernier scale division. So 10 main scale divisions minus 9 Vernier scale division. That would be the least count. Okay. So in this problem, how much it will come? One main scale division was 1 millimeter, and this is Vernier scale division, right? 9 Vernier scale division. And one Vernier scale division we found, right? One Vernier scale division was 1.1 main scale division, right? Just divide this equation by 10. So 1 VSD will be 1.1 MSD, and 1 MSD is 1 millimeter. So 1 VSD is 1.1 millimeter. So this is 10 minus 9.9, which is 0.1 millimeter. So that would be the least count. Well, I'll give you a shortcut because doing so much will take time in exam. So the shortcut for this is simply you write the least count as equals to 1 VSD minus 1 MSD. Okay, so that would give you the same answer. 1 VHD is 1.1 minus 1. 1 MHD is 1 millimeter. This is 1.1 millimeter, so answer will be 0.1 millimeter. So in retrograde vernier calipers, use this formula directly to find least count. But my job was to make you understand how that formula is actually coming. Okay. Let's do one more question based on vernier calipers. But here even concept of elasticity is required. Okay. So here there is a steel wire. This is a steel wire, and they have attached some mass m whose value is not given, not required also. So this mass is usually kept to keep the wire tight. Okay. Now they have attached here a vernier scale whose zero is at this end of the wire. Okay, so at this end of the wire, the zero of the vernier. So this is your vernier scale. Another wire is there which is called the reference wire, and on that wire there is a main scale attached. This is a main scale, and for the main scale the least count is given as 1 millimeter. Be careful, by least count of main scale they mean this gap. So they are not saying least count of vernier caliper, okay, not this system, but only for the smallest division between two marks in main scale. So that is given as least count. That is also least count for main scale, right? Least count means the smallest measurement that you can do with the instrument. So for only main scale, the smallest division is 1 millimeter, which is given as least count. So when mass of this load is increased by 1.2 kg, it will fall down, right? And therefore the vernier will come down. As it comes down, which division of vernier coincides with main scale division, that we have to find. So right now the zero is coinciding. So as the wire stretches, which division of vernier will coincide? So to find that, let us first calculate how much the zero will come down, and zero will come down by same amount as the wire will stretch, isn't it? So to find the change in length, we will use Young's modulus formula. Stress, force by area by strain, delta L by L. L will go up. So what will be delta L? FL by Y. Remember, we want change in length due to the additional force. So this M is not important for us, only the mass which was increased, because that is the increase in the length, because we are counting the initial length from here, right? So what is the extra mass added? 1.2 kg. So the extra force will be M into G. G is given 10, right? So force is delta M, the extra mass added into G. Okay, because this L was the length when already M is there. So after that, delta L was created by this extra mass. Okay, the length of the wire was actually 1 meter. I should have given this. Okay, so this length is 1 meter with this M attached. Okay, so initial length when only M was there, that time the initial length was 1. Young's modulus is 2 into 10 power 11. Area is pi r square. Diameter is given 0.5. So radius will be 0.5 by 2 millimeter. If you convert into meter, will be 10 power minus 3 pi r square, right? So we have to write pi r square. Now if you simplify this, you can take the value of pi as 3.2. The calculations will be easier. The answer will come 3 into 10 power minus 4 meter. Please try to do it yourself, okay? So that can be written 0.3 into 10 power minus 3 meter, which is millimeter. So the increase in the length of the wire is 0.3 millimeter. That means this zero of the vernier went down by 0.3 millimeter, right? So initially this was the zero of the main scale. This is the 1 millimeter mark. This is the 2 millimeter mark, and so on. Initially this is where your zero of the vernier was there initially, but now we came to know it came down by this much. Now this is not crossing 1, remember, this is 0.3, so the zero of the vernier may be now here. So this is the 0 of the vernier now. And this distance moved is nothing but the amount by which the wire came down. And the formula for that L we already know, right? Main scale reading plus coinciding vernier division into least count of the vernier caliper, not least count of the main scale. Okay, so this is basically 1 MSD. Now here the 0 of the vernier is between this division and this division, therefore the main scale reading should be the lesser one, so 0. This we don't know. And least count of the vernier caliper, what is the formula? 1 MSD minus 1 VSD. Here we can use this formula, right? So 1 main scale division is 1 millimeter minus, how to find 1 vernier scale division? Well, this information was given. So 1 vernier scale division is 0.9 MSD and MSD is 1 millimeter. So 1 VSD is 0.9 millimeter, which is 0.1 millimeter. So 0.1. And this L is the distance by which the 0 of the vernier moved, which is also the distance by which this end of the wire moved, which is 0.3. So from here if you simplify, N will come out equal to 3, right? Let us now discuss screw gauge. Screw gauge in general have better precision than vernier calipers because they have smaller least count than vernier calipers. Let us see why it is like that. This is the construction of a normal screw gauge, and we have two jaws, just like we had two jaws in vernier caliper. One of them was fixed and the other was movable. Here the fixed jaw is called stud and the movable one is called anvil. And how do you move it? By rotating this screw. Okay, now one part of this screw gauge here will remain fixed during this rotation. Okay, so as you rotate the screw, this circular thing will rotate around this fixed cylinder. Okay, now here the fixed scale here is what is called the main scale. This main scale will have markings which are sometimes in millimeter, meaning the divisions, the distance between two consecutive markings will be in millimeter, or in some cases it will be 0.5 millimeter. And here there will be a circular scale, and the circular scale will have normally 50 or 100 divisions, okay, total. Now just like in the case of vernier caliper, before you start the experiment you need to move the screw, rotate it so that these two jaws will touch. So now let's learn how to find the zero error in case of screw gauge. So first, as I told, the jaws should meet, and that time when the jaws meet, if the 0 of the circular scale, so wherever is the 0 of this circular scale, if it is in line with the reference line, this is called your reference line of the main scale or the linear scale. So this is the main scale or the linear scale, okay, or linear scale. So if the 0 of the circular scale is in line with the reference line of the main scale, then we say there is no zero error. So zero error is equal to 0 in this case. Okay, try to remember this. And the 0 of the when these two will touch, you will find that this circular scale will reach here. Okay, will reach here. That means this 0 will be only slightly visible, maybe, okay, slightly. Now in the second case, if the 0 is below the reference line, that means this is 0, so this is the first circular scale division, first, second, third. So you can see the third circular scale division coincides with the reference line. So 0 is below. Then we say zero error is positive. And what is the formula to calculate this? Whichever is the coinciding circular scale division, so whichever division is coinciding here, so circular scale division which is coinciding into the least count. And how to find the least count of the screw gauge we will discuss later. So this is very similar to how we did in Vernier calipers, right? And here and in this case the zero error is positive. So I hope you remember in your final reading this should be subtracted because here zero error is positive. And if the zero is above the reference line, here even here the zero of this main scale may be slightly visible, because as I told, when you touch these two, this circular scale will almost reach here, okay, the zero of the linear scale. So here also the zero of the linear scale may be slightly visible here, but here the zero of the main scale will not be visible, okay. So in this case the zero is above the reference line, right? So if this is 50 division, this may be 49, this will be 48, and this is 47. So in this case your zero error is negative, and I hope you remember, just like in Vernier calipers, if total has 50 division, then 50 minus whichever is coinciding, for example here 47 is coinciding, into least count. Or you can just count from here, okay. So from here if you count down 1 2 3, so 3 into least count. So that is how we have to do it, okay. So here 3 into least count, here also 3 into least count, but this is negative zero error, negative zero error, okay. Now if you want to measure the thickness of this marker, you have to put this in between these two, okay. So first you have to touch both of them, find the zero error, check for zero error, and then unscrew this, keep this marker inside, and once it is inside, make it slightly tight here, okay. So these two ends, these two jaws should just touch this marker. So how much distance this circular scale moved from here, right side, from here it started, right side, how much this circular scale moved right side, that distance is also the same as how much this has moved right side. So that distance formula is, let me give you directly the formula. It is your main scale reading, also sometimes we call it linear scale reading, which is found from the main scale, plus the circular scale division, which is coinciding with the reference line, okay. So this is the coinciding circular scale division, coinciding with whom? Coinciding with the obviously reference line, okay, into least count. So this is the formula to find the length of the object which is in between the two jaws. So now next we have to see who are these quantities. What about main scale reading? What is this reading? As I told you, for example, let's say this is the situation right now. So whatever is this division, that is your main scale reading. So when you keep this object, I told you have to unscrew this, right? So this circular scale will go towards the left side. So whichever mark on the main scale is visible, okay, nearest to the circular scale, left side. So this visible mark you have to consider as the main scale reading. We will do some example, you will get to know. And so this you understood, this you understood. Now let me quickly tell you how to find least count. So the formula for least count is pitch divided by number of circular scale divisions, total number of circular scale divisions. Now what is the meaning of pitch? Pitch basically means distance moved by the circular scale on the linear scale when one rotation is completed or one rotation is given. So when you give one rotation to this circular scale, how much this line this circular scale moves on the linear scale, how much it moves, that is called pitch, okay. So distance moved by this line as you rotate the screw and when you complete one rotation, the distance moved along this line, this distance moved, that is called pitch. Now most of the times, if this is your linear scale and these are the markings, okay, and right now let's say your circular scale is here, when you give one rotation this way, the circular scale will reach here. So it has moved by a distance equal to the distance between two markings. So usually this pitch is nothing but one main scale division in the main scale. Okay. Now how these formulas come, if you really want to know, then see here. This is your reference line, right? And this is also the main scale. Here 0 is there and 1, 2, 3, 4, 5, 6, 7, 8 like that. Isn't it? Now when the two jaws meet, and let's consider no zero error right now, then time what will happen, I told, this circular scale will coincide with this 0, and here the 0 will be, the 0 of the circular scale will lie. Okay. So this is how the situation will be. Now in order to keep some object here of length L, some, let's say a circular object, you have to unscrew this, you have to unscrew this. So let's say you gave 5 rotations and you reach, let's say 1, after 1 rotation you reached here, 2 rotations you reached here, 3 rotations you reached here, suppose. Then how much distance it moved here? 3 into this distance covered in one rotation is pitch, right? I told you. So there will be 3 into, this is one pitch, distance moved by circular scale in one rotation. So if you gave 3 rotations, complete rotations, then your 0 will again come here only. This 0 will again come here, 1 rotation, 2 rotation, 3 rotation, right? So what will be your main scale reading now? So you can see here 0, 1, 2, 3. So just this line is just coinciding with 3 exactly. So your main scale reading will be 3. And if it is in millimeters, then 3 millimeter, isn't it? What about your circular scale division, which is coinciding with the reference line? 0 itself is coinciding because I did complete 3 rotations. So this is 0, and least count would be the pitch divided by number of divisions in the circular scale. So here the reading would be what? Formula was main scale reading 3 millimeter plus circular scale division coinciding with reference line into least count, but this is 0. So the answer would be 3 millimeter, which makes sense also, right? Because I gave 3 complete rotations, right? And during each rotation I told the circular scale went from here to here, and this is 1 millimeter. So how much distance I moved? 3 millimeter, and that is the length of the body kept here. Now sometimes it may not be 3 complete rotations, right? I may give 3 rotations and then I may have reached here. Okay, so this is 3, I know. So now this is not there, you have to focus on this part. So after giving 3 rotations I reached here, so till 3 rotations I reached here, then I must have given some rotation, not complete rotation, but some rotation to reach here also. Now how to find that? Well, in one full rotation, what is the distance traveled? One full rotation, one full rotations, I covered one pitch, right? So when I give one full rotation, I covered one pitch. The circular scale covered one pitch, which would be in this case this distance, 1 millimeter. But from here to here, I did not give one complete rotation. Now one full rotation means what? If there are 50 divisions, right? Because one full rotation has 50 divisions. So 50 division would be one pitch. But because I did not give one complete rotation, the 0 will not come back here, right? So as I am going like this, so 0 was here, right? So as I am giving rotation like this number here may be 30. So if 30 division is showing here, if the 30th division on the circular scale is coinciding with the reference line, then how many rotations I gave from here to here? 30 divisions I gave rotation equal to. For full rotation I have to give 50, right? Understood that part? Look here. So let's say this is the reference line, 0 is here right now. Okay. So if I give one full rotation, 0 will again come here. Now you know that 0, 1, 2, 3 is there. And I am rotating this way, right? To unwind. So if while doing like this, if 3 comes here, if 0 comes back means I have given full rotation. But let's say here 3 comes. This 3 is here. Then it means I have given 3 rotation, right? Because I am rotating this way. So this 3 rotation I have given. So 3, 2, 1. So this much rotation I have given. 3 rotation if 3 is shown here. So if 30 is shown here, I have given how many rotations? Equal to 30 divisions. So 30 divisions will be equal to how much distance moved? Well, 50 divisions corresponds to 1 pitch. So 1 division will be 1 by 50 pitch. And if 1 division is 1 by 50 pitch, 30 division will be what? 1 by 50 into 30 pitch, which is nothing but 30 into pitch divided by 50. And this pitch divided by 50 is what I told before, least count. Yes or no? And this 30 is what I told, circular scale division, which is coinciding with the reference line. So now what will be the answer? This much is visible, right? When this circular scale is here, this mark will, this linear, this will be visible. So 0, 1, 2, 3. So main scale reading is 3, right? 0, 1, 2, 3. And from here to here, this extra distance, how I found? This way, which is plus, this is your main scale reading, plus coinciding circular scale division into least count, isn't it? So I hope you got the idea. Again, no need to think about this so much. Try to remember the formula and use it. Okay. So let's do the first question in screw gauge. We have to find the diameter of a steel ball. The least count of screw gauge is given directly. We don't have to calculate. Main scale reading is given 5 mm directly. The 25th circular scale division, the 25th one on this, I don't know how many divisions are there, not required also, but we need to know which division coincides with the reference line. Okay, so it is given 25th. Zero error is mentioned, negative, so we have to find the correct diameter. So first let us calculate the measured length. So what is the formula? In screw gauge, the main scale reading plus coinciding circular scale division with the reference line into least count. Now main scale reading is given 5 mm. That can be written as 5 by 10 centimeters or 0.5 centimeter, right? Because all the other values are in centimeter. So main scale reading is 0.5 centimeter plus the circular scale division which coincides with this line is 25 into least count is given 0.001. So that will come 0.5 plus 0.025. That will come 0.525 centimeter, right? And since zero error is negative, the true answer will be 0.525 plus the magnitude of the zero error, which is 0.004, which is 0.529 centimeter. So that would be the answer. Okay. Let's discuss another problem in screw gauge. So in the screw gauge, the total number of circular divisions in the circular scale is given 50. So total number of divisions in this circular scale is 50. It moves 1 millimeter on the main scale in 2 complete rotations. So when we give 2 complete rotation, the circular scale moves 1 millimeter on the main scale. So this is given to find the pitch, okay? And from pitch and this we can find the least count. And we have to find the diameter. Now when the jaws are meeting, they have given you this diagram of the linear scale and the circular scale. That means from here you can find the zero error. and from here you can find the reading, because this is when the ball whose diameter we want to measure is kept between the jaws. Okay, so let's first find the pitch. What is pitch now? It is the distance moved by circular scale in the main scale in one complete rotation, right? So in 2 rotations it moves 1 millimeter, isn't it? So distance moved by the circular scale divided by number of rotations given, isn't it? Right? So pitch would be how much distance it moved divided by number of divisions. So that number of rotations. So that will give you distance moved in one rotation, because you are dividing by number of rotation. How much distance it moved? 1 millimeter. So number of rotations given here is given 2. So 0.5 millimeter. And the pitch would also mean this distance here. Okay. So that would be 0.5 mm. Once we have found the pitch, now we can find the least count. So least count is what? Pitch 0.5 mm divided by number of divisions 50. So that will be 0.1 by 10, which is 0.01 mm. So this is the least count of the screw gauge, right? Now using this diagram, when the jaws meet, we have to find the zero error. So let's do calculation for zero error. Okay, so you can see the 0 is below, and therefore your zero error is positive, right? How much it is? The circular scale division, which is coinciding with reference line, is 5 into least count, and least count is 0.01, so it is positive 0.05 mm. So zero error we found. Now we can calculate the measured length or measured diameter, right? So what is the formula? Main scale reading plus circular scale division coinciding with reference line, or circular scale reading into the circular scale division coinciding with the reference line into the least count, right? Remember, this was your least count. Now what is the main scale reading? Remember, I told you whichever is visible, right? Whichever mark on the main scale is visible, right? So you can see 0, 1, 2, but this division is 0.5. So this is 0, 0.5 mm, and this is 1 mm, right? So 1 mm is the main scale reading, isn't it? Because this is 0, 1, 2. This is 2 divisions of main scale, correct? But one division of main scale is 0.5 mm length. So 2 division will be what? 1 mm length. Okay. So this distance is 1 mm plus what is the circular scale division coinciding with the reference line? 25, and least count is 0.01. Okay. So again I am saying this 0, 0.5. So next one will be what? 0.5 plus 0.5, which is 1 mm. So that is 1 mm, 1.25 mm, right? Now zero error is positive, so we have to subtract that to get the true reading. So the true diameter will be measured diameter minus 0.05. That will be 1.20 millimeter, and that would be the final answer, right? Now let's do a question where both vernier caliper and screw gauge is mentioned. Okay, so we have the least count of vernier and screw gauge in the ratio 5:1. It is given. So their least count ratio is given. Okay, values are not given. The main scale of both have 1 MHD equal to 1 millimeter. That means one main scale division. Distance between two consecutive marks in the main scale is 1 millimeter. Zero error of vernier scale is given plus 0.15, and for screw gauge is minus 0.06, both in millimeter. The diameter of the rod which they are measuring using these two instruments, the diameter of that rod lies between these two numbers. Therefore, whatever answer will come will be 0.9 something centimeter, okay? Because it is between these two, right? So you can think of the zero of the vernier is between these two, right? So the answer will be 0.9 something. And if X and Y are the VCD and CSR, what are these two? Well, they should explain. This is actually the coinciding vernier division, right? So that division in the vernier which coincides with one of the main scale division. And this is your circular scale division or reading which coincides with the reference line in screw gauge. So these two values are X and Y for vernier caliper and screw gauge, and they are asking what should be the relation between that X and Y out of these four options. They are asking you to take the total number of divisions, circular scale divisions, to be 100. So first thing what we can do is we can find the least count of screw gauge, right? So for least count of screw gauge, if you put S here, okay, what it would be? Pitch divided by number of divisions in the circular scale. Now pitch they have not told, but as I told you, when you do one complete rotation, your circular scale will move by one main scale division. So if this is your main scale division, one mark is here, one mark is here. If your circular scale is here right now, after one complete rotation, it will move here. Okay, if you are tightening it, if you are loosening it, it will go here. Okay. So that gap is called pitch, which is here 1 millimeter, right? Distance between two marks in the main scale. So 1 millimeter divided by 100. So what would be the least count of the screw gauge? 0.01 millimeter. Try to remember this. Now for vernier, they have given a ratio, right? So here let me write least count for vernier scale divided by least count for circular scale. Ratio is given 5:1. But for screw gauge, we found it is 0.01. So if you cross multiply, least count for vernier will be 0.05. Correct? So whatever is the length that they are measuring, that length should be, according to vernier, it should be main scale reading plus coinciding vernier division or VCD, as in this question they told, into least count for vernier. And what is the main scale reading? Well, that is 0.9 because it is between these two, right? So 0.9 plus, remember it's centimeter, okay? Coinciding vernier division. What is the coinciding vernier division? It was X, right? And least count of vernier is 0.05 mm. But this was in centimeter. So if I write in millimeter, I have to multiply by 10. So if I multiply by 10, this will be 9 millimeter. So let me write in millimeter only. So 9 millimeter plus X into least count of vernier is 0.05 millimeter. But this is only the measured value, isn't it? The vernier caliper has a positive error. So we have to subtract minus the error, which is 0.15 mm. So this will come equal to 9 mm minus 0.15 mm will be what? 8.85 mm, right? Plus X into 0.05 mm. This is the answer of the length measured using vernier calipers. Now same answer using, this is for vernier, using screw gauge. Now for screw gauge we have main scale reading again plus circular scale reading into least count of screw gauge, and this time the error is negative, so we have to add the magnitude of the error. So even this time main scale reading is 0.9 centimeter, which is 9 mm. Circular scale reading is Y, we don't know. Least count of screw gauge is 0.01 mm plus E is how much? For screw gauge is 0.06. So this will come equal to D equals to 9 plus 0.06 will be 9.06 mm plus Y into 0.01 mm, right? This is your equation 2. Now since both are measuring the same object, so these two should be same, right? The length of the true length of the object has to be same. So therefore we can equate this one with this 8.85 mm plus x into 0.05 mm. So you can bring this 8.85 here, so that will be 9.06 minus 8.85, it is 1, this will be 10 minus 8, 2.0, so 0.21, right? And that side you can take x into 0.05 minus y into 0.01. If you multiply with 100 both the sides, you will get 21 is equals to 5x minus y. So you can see which option is this. Let's see another question where there is vernier calipers and screw gauge. Okay. So in vernier scale, 1 centimeter on the main scale of vernier caliper has 8 equal divisions. So that means from here 1 MSD. Okay. 1 centimeter has 8 divisions. So one division, one main scale division will be how much? 1 centimeter by 8. Okay. So this is 1 MSD. In screw gauge, there are 100 divisions on the circular scale that we have to remember. In vernier, 5 vernier scale divisions equals 4 main scale divisions. So this is our normal vernier. So here I can write 1 vernier scale division is equal to 4 main scale division divided by 5. Just divide by 5. And 1 main scale division just now be found, right? 4 by 5 into 1 main scale division is 1 by 8 centimeter. 4 2s are 8, 1 by 10, 0.1 centimeter. So we have already found 1 VSD for which instrument? Vernier. Okay. In screw gauge, one complete rotation moves circular scale by 2 divisions. So by 2 divisions it moves on the linear scale. So here pitch is given twice the least count. We have to find least count of vernier caliper. Okay. So pitch of the screw gauge is given twice the least count of vernier caliper. We have to find least count of screw gauge. Now for finding least count of screw gauge, we know the formula, right? We need to find pitch, then divide by the number of circular scale division. Number of circular scale division is given directly 100. So we have to just find the pitch, then divide by 100, isn't it? Now pitch to find, here they have given pitch is twice of least count of vernier caliper. So done. Least count of vernier caliper, how to find? Normal vernier it is, right? So 1 MSD minus 1 VSD, isn't it? So least count is 1 main scale division is 1 by 8 centimeter minus 0.1 centimeter. 0.1 means what? 1 by 10. So this, if you simplify, you will get here 80, 8 tens are 10, 8s are 2 by 80, 1 by 40 centimeter. So that is the least count, isn't it? For whom? Vernier caliper. Once you know the least count of vernier, what will be the pitch now? Because pitch is twice of least count of vernier. So twice of 1 by 40 centimeter, isn't it? Then you have to divide by 100. So that is the answer for least count. So that will be 1 by 2 and 2 1s are 2, 2 2s are 4. So 1 by 2000. which is 1 by 2000 will be how much? 0.5 into 10 power minus 3. That would be the least count. Now in what unit it is? Centimeter, right? And 0.5 centimeter is 5 millimeter. So 5 into 10 power minus 3 millimeter. That is the answer of this question. Okay. Let's solve the next question. Students A and B are using two screw gauge of equal pitch 0.1 centimeter, and those screw gauge have 100 equal circular divisions in the circular scale, and they are using it to measure radius of a wire. So the wire is same. The actual value of the radius is 0.322 centimeter, remember. So it did not cross 1 centimeter, remember that, okay. The absolute value of difference between circular scale reading. So circular scale reading means what? That circular scale division which is coinciding with the reference line observed by A and B while measuring the radius. Now you may think, what are these two diagrams here? Already circular scale reading is given 5 here, 92 here. No. These are when they told here, figure here shows when the jaws are closed. And when jaws are closed, this figure is to measure what? Zero error, right? Not the actual diameter. So to measure the diameter or radius of a wire, you have to put the wire in between the jaws, right? You should not close the jaws. So they are asking difference in the values of circular scale readings when there is wire in between the jaws. So what will be the zero error for student A? Well, for student A, you can see if you turn this one this way, the zero of the circular scale will be below the reference line. So zero error is positive. And this is coinciding, so 5 into least count, isn't it? Least count we can measure. Least count is pitch divided by number of divisions in the circular scale, which is 100. So 0.1 by 100 would be 0.001 centimeter, isn't it? Correct? Okay. And what would be zero error in case of this body? In case of the second screw gauge. Well, here 92 is coinciding, so 0 will be above, right? If you turn this way, 0 will be above. So this is negative zero error, and there are 100 divisions. 92 is coinciding, so 100 minus 92 into least count, which means 0.8. 8 into least count, right? Okay. Now this is the value given for the true value, right? So try to remember this. Let me mention it. The actual value of radius is 0.322 centimeter. So this we need. This is the zero error of the second of the instrument used by the second student. This is zero error for the first student. Okay. Now we are left with these three information, right? So what will be the true diameter for student A? Okay. Main scale reading plus circular scale reading, which we don't know, into least count, and we have to add or subtract. For first student, this is for student A, zero error is positive, so it will be minus 5 into least count, correct? So now this can be written as D equal to main scale reading plus, here you can write circular scale reading, let me write as X, minus 5. I can take least count common, which is 0.001 centimeter, right? Now for second student, when you write the diameter of the same wire, it will be main scale reading plus circular scale reading into least count. Now difference will be in the error, right? So here error is negative, so we have to add the modulus of this, so it will be 8 into least count. And if I take common, let me substitute for circular scale reading for student B as y plus 8 into least count is 0.001. Now both are giving the same reading, so we can equate these two, and when you equate these two will cancel, right? Because same wire we are measuring with the two screw gauge, so main scale reading will be same. This happened to be different because of the errors involved, right? So these two are same, so when you equate this and this will cancel, so you will get x minus 5 into least count will be equal to y plus 8 into least count, which means even least count will get cancelled. So if I bring y this side, I'll get x minus y equals to 5 plus 8, which is equals to 13. So difference in the circular scale readings will be 13 for the two screw gauge measured by the two students, right?